Hello everyone. Today we will see where we encounter series in calculus. So in calculus we encounter series in two places, that is Sandwich Theorem and Riemann Sum. So now first let's see what is Sandwich Theorem. So Sandwich Theorem says that if we have three functions hx, gx and fx, and gx lies in between hx and fx, then if we take limit x tends to some a on all of them, and this was the first condition. The second condition is that if limit of x tends to a hx and limit x tends to a of fx is equal to L, that is both of them have same limit, that is L, then we can find that g will also have value L. Why is that so? Because as you can see in this in this graph, that this is fx, right, and this is hx. So gx wants to remain in between both of them. So it is only possible at this point if gx equals L, right? Because both of them, fx and hx, has value value of L at x equals a. So gx must also be L. Only then this condition is possible, right? So let me summarize what this theorem says is that first we need to find two functions hx and fx such that hx is lower and fx is greater than gx. The second condition is they both be such that the limit of x tends to some a hx should be equal to limit x tends to a fx. And if these two conditions hold, then what we can say is that limit x tends to a gx is also equal to L. Right, now let's see a question on this. So here we have been given that fx is an increasing function and limit x tends to infinity, f of 3x by fx equals 1. Then we need to find limit x tends to infinity, f2x by fx. So try solving it yourself, then we will see it. So now let us solve it. So first let's draw a graph that, let's say this is f and this is x, 2x and 3x. Right, now what we can see is that f of x is less than equal to f of 2x, and this is less than equal to f of 3x. Right, now what we need is we need to divide it by fx. So let's divide by fx. Right, now fx by fx, this is 1, so let's write here as 1. Now what we need is limit x tends to infinity. So let us take limit x tends to infinity. Here also limit x tends to infinity. Now this is a constant, so limit x tends to infinity is also 1, as it has graph like this. So let's write it as 1, and this is less than equal to limit x tends to infinity f2x by fx, and this is what we need to find, and this is less than equal to this, and what is this? This is equal to 1 as given here. So now what we have is this value is between 1 and 1, and that is only possible when it is equal to 1, right? So this is the answer. Now let's see the next question, which is this one. And in this question we will see how to solve series with the help of Sandwich theorem. So this is the series with the 2n plus 1 terms, and it is 1 by under root n square plus 1 by under root n square plus 1 and so on up to 1 by under root n square plus 2n. So try solving it yourself, then we will see it. So now let's solve it. Now as you can see, we need to find two functions, one that is less than this complete series and another that is greater than this complete series. So how we can do it? So to do that, what we know is that 1 by under root n square plus 2n. This is the smallest term of this series, as it has the greatest denominator, right? So if we add this 2n plus 1 times, then this will be a series that has value that will be less than this complete series, right? So this is less than equal to the series that we require, that is n square plus 1 by under root n square plus 1 and so on. And the other series that we want is that should be greater than this. So how we can make it? So to make that, this is the greatest term of this series, as it has the smallest denominator. So if we create a series by adding this 2n plus 1 times, so we get a series that is greater than the required series. So now we have created two functions. Now let's see if they have same value of limit. So if we take this limit n tends to infinity, so it is equal to, now we are adding it 2n times, so it is 2n plus 1 divided by under root n square plus 2n, and limit x tends to infinity, sorry, n tends to infinity. Now as you can see that it is infinite by infinite form, and the degree of numerator and denominator is same, right? So the answer is 2 here. Now let's see what is the limit here. So it is 2n plus 1 divided by under root n square, that is 2n plus 1 divided by n, and limit n tends to infinity. Now here also this is infinite by infinite, so the answer to this is 2. So they both have same limit, so the required value is less than equal to 2 and greater than equal to 2. This is only possible if it is equal to 2. So this is the answer. So I hope you understood how to use Sandwich theorem to solve series. Now let's see the next question. So try solving it yourself, then we will solve it. So now let's solve it. So there are multiple ways to solve this question. So let's first solve it without Sandwich theorem. So what we can say is that greatest integer x is equal to x minus fractional part of x, right? So each of these terms can be written as x minus fractional part x plus 2x minus fractional part 2x and so on up to nx minus fractional part of nx, right? And this is equal to x plus 2x plus so on up to nx minus fractional part x plus fractional part 2x and so on till fractional part nx. Now this is equal to x into n into n plus 1 by 2, right? This is 1 plus 2 plus 3 and so on up to n, so that is n into n plus 1 by 2, and minus, now as you know that fractional part x is less than 1 and greater than equal to 0, so this complete sum will be between 0 and n. right? So now let's say this is something between 0 to 0 to n, right? And this is now divided by n square. So if we take the limit uh, that n tends to infinity, so this is with uh, n raised to the power 1 power at max, and in the denominator we have n square. So this is insignificant, and this will become 0 if we take n by n square, right? So just ignore this. Now what is left is x into n into n plus 1 by 2 divided by n square. So here also what we have is infinity by infinity form. So this after solving this becomes x by 2. So this is the answer. So here we have solved it without using Sandwich theorem. Now let's see how to solve this with the help of Sandwich theorem. Let me just remove this. Now we know that x is greater than equal to x minus greater integer x is greater than equal to x minus 1 and less than equal to x. For example, if we have like 3.14, so its greatest integer is equal to 3, that is less than this. And there is a equality only if this is an integer. For example, greatest integer of 3 is 3, right? So we can say this. Now let's write this for all of the terms that are in the series, that is 2x minus 1 is greater than equal to greater integer 2x and less than equal to 2x. Similarly, so on till nx minus 1 less than equal to this and less than equal to nx. Right, now let's add all of them. So on adding we get x plus 2x plus so on up to nx minus, we have to subtract 1 n times, so this is n, this is less than equal to greater than x 2x and so on up to nx, and this is less than equal to x plus 2x plus so on up to nx. Right, now what we need to do is divide by n square. So let's divide by n square. Right, now as you can see we have created a series that is lower and a series that is greater than the required series. So if we take limit, let's take the limit for this. Limit n tends to infinity, and this is what x into n plus 1 by 2 minus n divided by n square. So the value of this is equal to x by 2, right? And this is less than equal to the required value. And let's take the limit here also. Limit x tends to infinity. This is x into n plus 1 by 2 and divided by n square. So this is also equal to x by 2. So now you can see that the lower and the upper both have limit x by 2. So this is only possible if this is equal to x by 2. So this is the answer, right? Now let's see what is Riemann sum. So we know that if we have a function fx, right, and if we have an interval, let's say from 0 to 1, and we divide this interval into n equal parts, so we have 1 by n and then 2 by n and then so on up to n by n. So we divided it into n equal parts, and now we create these rectangles, that is the value at 1 by n, that is this, and we create this rectangle. So what will be the area of this rectangle? That will be this value, that is 1 by n, this thickness, and the height is uh, the function with x equal to this. So that is f of 1 by x into 1 by n. Similarly, we create all the rectangles, and now the second rectangle will have area 1 by n, as this thickness is 1 by n, into f of 2 by n, because we have value 2 by n here. So similarly, if we create all the rectangles and sum them up, so that will be 1 by n, f of 1 by n, plus 1 by n, f of 2 by n, plus so on up to 1 by n, f of n by n. Right, so this is summation 1 by n, f of r by n, and r equals 0 to, sorry, 1 to n. Now what we will do is, we will take the limit n tends to infinity. So what this means is that we have squeezed this thickness to very small value, and what this means is that eventually we are taking the area under the curve. As you can see, if we take very small rectangles, so this area, another very small rectangle, so this area, and so on. Finally, what we will do is, we will take the area under curve for this complete curve, right? This area, this whole area. So what this area is, this is integration from 0 to 1 fx dx, right? So we converted this summation with the limit to this integration. Right, now we will use this solve series questions. As you can see, we have created some kind of series here. The only thing we need to do is to figure out what this function is, and to convert this into this form, right? And then we can just convert it into integration. Now let me write the steps that you need to follow to solve such questions. Now here I have written all the steps to solve all such questions. So step 1 is to convert the whole series to summation form, right? And this we are doing from last many videos, so this is a very easy step. Now the second step is to convert summation f of r from r equal to a to b in the form f of r by n into 1 by n, right? So to do this, you may need to take some n common out or something like that, but this is also very easy step. Then the third step is to make some replaces. So we need to replace summation by integration 1 by n to dx and r by n to x. Then the step 4 is to find the lower limit and upper limit of the integration. So the lower limit of integration is a by n, and limit n tends to infinity. Now what is a? A is the lower limit of the summation, right? And similarly we will find the upper limit, that will be b by n, and n tends to infinity. And finally we need to find this complete integral, that is fx dx, and limits are the one we found above. Now let's see some questions on this. So try to solve it yourself, then we will solve it. So now let's solve it. So the first step is to write this in summation form. So let's write it in summation form. So this is summation n by n square plus r square, and r is from 1 to n, right? Now the second step is to write it in the form r by n into 1 by n. So to make r by n here, we will take n square common from the denominator. So this is summation 1 by n square into n by 1 plus r by n squared. Now this n and this cancels out, and limits are from 1 to n. So we have written this in r by n form, and we have a 1 by n here. Now we will write this in the integral form. So this is integral, sorry, this is 1 by 1 plus x square dx. Now let's find the lower and upper limit. So the lower limit is 1 by n, limit n tends to infinity, and this is 0. The upper limit is limit n tends to infinity and n by n, that is equal to 1. So this is integral from 0 to 1. Now you can just integrate it and put the limits. This is tan inverse x, and limits are from 0 to 1, and you can find the answer. Now let's see the next question. So try solving it yourself, then you will solve it. So now let's see it. So in this question, as you can see, there is no such series that you can see at this moment, but let's try to solve it. So this is first of all infinity by infinity to some zero form. So since powers are included, let's use log to solve it. So let y equals n factorial by n to the power n raised to the power 1 by n. Now let's take log both sides. So this will be log y equals 1 by n log, let's write n factorial as 1 into 2 into 3 and so on up to n, and the denominator as n into n so on n times. Right, now we can just use the log property and break this product into sum. So this is equal to 1 by n log 1 by n plus log 2 by n and so on up to log n by n. So now here you can see the series. So the next step is to use the summation form. So this is equal to 1 by n summation log r by n. Now this is already in the form r by n into 1 by n, and the limits are from 1 to n. Now let's convert it into the integral form. So this is integral f, sorry, log x and dx. Now the upper and lower limit are again from 0 to 1 as we saw above. Now you can just integrate it. Let's so the integral will be x log x minus x. Let's say it is I. Now y will be equal to e to the power I. So you can get the answer. So I hope you understood this question. This is like a really special question where there is no series as you can see initially, but while solving eventually you encounter this expression which turns into a series. And if you don't know how to solve this using integrals, it will be really difficult to solve it. So in this video we saw how to solve series with the help of Sandwich Theorem and Riemann Sum. So this was the first part, and in later parts we will see some other series such as P series, convergence, divergence, etc. So thank you and see you in the next video.